Okay, so here you have problem number one. We have a long wire that carries current. The current is given. Magnetic field, we have to find magnetic field at a radius of 4 meters. Okay, so how can we find it? Now, when you have a long wire, let's say current is moving upwards, you have to use right hand rule to find the magnetic field. So magnetic field will be everywhere of this wire. Okay, now it will be B will be inverse proportional to the radius. So that means as radius is getting bigger, the field becomes weaker. So in this case, we have to find, let's say, the magnetic field at a distance of r. So the formula will be is basically B is equal mu naught current divided by 2 pi r. So this is a basically formula. You substitute values. The current is given. Radius is given, and mu naught is always constant. We use it 4 pi times 10 to the power of minus 7. Okay, this is the first problem. The second problem, we have transmission line strung 8 meters above the ground, carries a current. What is the magnetic field on the ground directly below the wire? So we have here basically a wire. Let's say current is moving to the right, and we have here a ground, and in the ground the distance is given. We have to find magnetic field just here. So if you use right hand rule, then as you can see, it basically will be like magnetic field going like this way. Okay, so if you look at that one, then here magnetic field will be out of the page, and below it will be into the page. Okay, so how can we find at this distance? So again, using same formula, B is equal mu naught current divided by 2 pi r. So in this case, instead of r, we have to use a d. So mu naught current 2 pi d. So we have to find magnetic field particularly at this point. Okay, third question. We have two long parallel wires, shows in the accompanying figure, carry current in the same direction. If the current 10 ampere, and the other one is 20 amperes. Okay, this is 10, this is 20. What is magnitude of the magnetic field at point P? Okay, so we have this wire, which is current 1, which is equal 10 ampere. Then we have here second wire that all have same direction, 20 amperes. So let's say we want to find magnetic field at point P. Okay, so this distance is given. Let's say this will be d1, and let's say this will be d2. Okay, again, using the right hand rule, we know that magnetic field that is coming from current 1 at P point will be into the page, so I call it B1. Okay, and magnetic field that is coming from current 2 will be out of the page. Out of the page, this is B2. Okay, so as you can see, one magnetic field into the page, there's one out of the page. So B total is basically, if you take the magnitude, let's say, we can say that B2, which out of the page, minus B1, which is into the page. Okay, the formula will be what? So the B2 will be equal to the mu naught current 2 divided by 2 pi, and distance is d2. Okay, for the B1, it is equal mu naught current 1 divided by 2 pi and d1. Okay, so if you plug it, then you should get the answer. Okay, next, problem number 4. in the problem number 4, two long parallel wires hang by a cord of the length 7 cm as shown in the accompanying figure. Okay, we have wait a minute. Okay, two long parallel wires carrying length 7 centimeter. Wires hang a cord of the length 7 centimeter shown the accompanying figure. Each wire has mass per unit length. They carry the same current in opposite direction. What is the current if the cord hangs at with respect to the vertical? Okay, so in this problem, basically we have to find the current, correct? Okay, let's start drawing it then. So the given values is basically mass per unit length, m over L, which is 30 gram per meter. You have to convert into kilogram meter. And if you look at from the side view of that picture, what you get basically like this one. And as you can see, the current are opposite. Okay, so let's say this one will be out of the page, so I call it current, and that one will be into the page. Okay, so when current are flowing opposite, they repel each other obviously, and this angle is given, let's say theta, which is equal to 6 degrees. So theta is equal to 6 degrees, and that distance is given, which is what was it, 7 centimeters. Okay, let's go 7 centimeters. We have to find a current. Okay. Okay. Now, since both currents are the same but flowing in opposite direction, okay, how can we find it? So first of all, let's pick up the left side and draw free body diagram of all forces on it. So first will be the force, which is mg. The other one will be magnetic force, FB. Then we have tension here, and since that tension at certain angle, it has to be resolved in two components. This one, this is theta, is this theta, so this the right side x component of the force will be t sine theta. The other one will be t cos theta. Okay, and that distance is, let's say it's r. Okay, now the r will be equal for 2d sine theta. That one is already derived in the previous classes. So we have to now find the current. So in general, we have a formula where we know that force, magnetic force, is equal current times L times B. Okay, and and we also know that if that one is the case, then we also have a formula where magnetic field is equal to the mu naught current divided by 2 pi r. Okay, if that's the case, and if we say that this is current 1, this is current 2, also they're both of them equal, we can say that B1, magnetic field B1 is created by the current 1. Okay, if that's the case, then we also know that force is equal current 2 L times B. Okay, L is a length, right? Then we also know that F over L is equal mu naught current 1 current 2 divided by 2 pi r. Okay, when you have two wires, since we know that current 1 is equal to current 2, then we can say mu naught current squared divided by 2 pi r. What else? Moreover, we can say that FB is equal to T sine theta, and MG is equal to cosine theta, right? So if you divide it to one to another, we should get FB is equal MG, T will cancel out, this is equal tangent theta, correct? What else? Okay. If that's the case, then we also know that R was equal to this value, correct? If that's the case, then F over L is equal mu naught current squared divided by 2 pi r. So instead of r, I want to put 2d sine theta. Okay, then it becomes what? It becomes F over L is equal mu naught I squared divided by 4 pi d sine theta. Okay. And you can also bring L into here. So we have F is equal to that one. Then what is next? We have FB can be equal. We also know that FB is equal, FB is equal mg tangent theta, correct? So if we equalize them, this both of them, then what we may get? So let me clean up this place. Clean up this place, and if I do that, okay guys, if I do that, mg tangent theta, which is FB, will be equal to the mu naught current square L divided by 4 pi d sine theta, correct? If that's the case, then we also know that M over L, right? So that means mg tangent theta multiplied to the 4 pi d sine theta divided by L mu naught, that is equal to current. And you have to take square root of everything. So M over L is equal to the 30 gram per meter, and tangent is given. Mu naught is 4 pi times 10 to the power of minus 7, and D is given 7 centimeters. Theta is given. I think that's it.